Sometimes you find yourself differentiating more than one variable with respect to time. Or what that means is sometimes you find situations in life where more than one thing is changing at the same time as time goes on, and we call those related rates. And that's because rates of change or derivatives, you have more than one rate, and they're all being related by the same equation. So future videos, the next 2 or 3 in this section, are going to be more like word problems. This one is just to kind of get you into the feel of how to take a derivative of a model or an equation with respect to time. And so I might give you a function, whether it's implicit or explicit. So y equals the square root of x plus 1, and I'll tell you to find dy dt, which is the derivative of y with respect to t when x equals 3 and dx dt is also 3. So the first thing we need to do is find the derivative of each side with respect to t, or with respect to time. So the derivative of y with respect to t, remember from implicit, that's just dy dt, because the letters don't match up. So the derivative of y with respect to t is not 1, the derivative of y with respect to t is dy dt. Okay, this is a shell that's a square root. Remember, that looks like this. And so what we're going to have to do is bring the 1/2 down, rewrite the base, take 1 off the power. So nothing about that changed, that's just the derivative of the shell. No matter what you're taking the derivative with respect to, bring the 1/2 down, rewrite the base, take 1 off the power, times the derivative of the peanut, or the inside, or the base. Derivative of x plus 1 with respect to t is dx dt. Okay, just to get you a good review or a good refreshing on what exponent rules are, 1/2 power means square root, negative means put this in the bottom. So dx dt is still up here in the top, but there's a 2 in the bottom and a square root of x plus 1. Again, 1/2 power is square root, negative means put that in the bottom. The 2 here was already in the bottom. Dx dt is up here on top. And so if this says find dy dt, that's right here, when dx dt is a 3, so that means that I need to put a 3 in for dx dt up here. And x is also 3, I'll put a 3 in down here for x. So 3 over 2 square root of 4, which is 3 over 2 times 2 is 4. Square root of 4 is 2. Square root of 4 could also be negative 2. You just have to check the context of the problem sometimes. But in this case, this would be 3/4. Okay, so that's how you do implicit differentiation with respect to t. It's the same exact thing as implicitly differentiating y with respect to x, just that this has a different letter. Here's another example, xy equals 4, find dx dt. Here's a bunch of information, this is what I need to find. So x times y equals 4. First derivative of the second, this is a product rule. So rewrite the first thing, derivative of y with respect to t is dy dt. First derivative of the second plus the second derivative of the first with respect to t, so that's dx dt. The derivative of 4 with respect to t is 0. Now, find dx dt. So I'm looking for dx dt is right here. X equals 8, that goes here. Dy dt is a 2, that goes here. And I see that it looks to me like I have an extra unknown, and that's because I do. I don't know what to stick in for y. Whenever you don't know what to, you're missing an ordered pair, like here's the x equals, you don't have the y equals. You can always remember that the original function always relates x and y. So you can come back to that. If x is 8, 8y equals 4, what would y have to be in order for this ordered pair to fit into this equation? So that would be 1/2. So this is a 1/2 right here. Okay, so this is very important. That is how you find the missing piece of an ordered pair. If it doesn't seem like you're getting enough information, you might need to go back and find the rest of the ordered pair. So 16 plus 1/2 dx dt equals 0. So 1/2 dx dt equals negative 16. So dx dt is negative 32. Alright, and that is how you find a derivative with respect to t, and also how you substitute in pieces to find a missing piece. And that's all this video has.